Welcome grade 12 to sequences and series. And of course, we look at arithmetic sequences and series and geometric sequences and series. And the main difference between arithmetic and geometric is that for arithmetic, the D, or the common difference, is being added or subtracted, whereas the difference in a geometric series, or the R, the common ratio, is being multiplied or divided. And of course, for an arithmetic sequence, this is the formula, basically the same formula we used, the linear pattern, when we did number patterns. This is the linear pattern formula. Okay, so we already looked at this. And the sum, or the series Sn, we have two possible formulas for that one. The one at the bottom, this one here, this is basically the one we would use if we have the first and the last term. Okay, if we have the first and the last term, we can use this formula at the bottom, which is much simpler. But if we do not have the last term, then we have to use the more general Sn formula, which is the one on top here. Let's put that to application. All right, this is obviously arithmetic, because you can see we're adding 5 each time. All right, so let's answer the questions. Find the number of terms in the sequence. All right, so before we can find the number of terms, we need to find Tn, the Tn formula. All right, so our Tn formula, let's just put it down in case you forgot. Just remind you, our Tn formula is A plus n minus 1 multiplied by the difference. A is the first term, which is 5 in this case. N minus 1, D is the difference. Difference is also 5. Okay. Okay, as you can see, we'll get 5n. Our Tn is 5n. Okay, so once we have our Tn, then we can answer this question. The question is asking the learner to find the number of terms in this sequence. Whenever you get a question like this that's asking you to find the number of terms, you'll find Tn first, and once you have your Tn, then you must equate it to the last term. Okay, once you have your Tn, you must equate it to the final term. I mean, the last term tells you how many terms there are, because it is the last of the terms. Okay, so if you take your Tn and you equate it to the last term, you should be able to find the number of terms in the series. Okay, so how many terms are there in the series? Let's check. 6,375, divide that by 5. So we find that we have 1,275 terms in this series. Okay, and we could work this out by using the last term. Okay, moving on. Now find the sum. Finding the sum, that means we need to use our Sn formulas. All right, so we can actually use the easier one, because we've got A, the first term, and we've also got L, the last term. So we can actually use the much easier formula. Okay, we know N. We know the number of terms is 1,275. Okay, our first term is 5, and our last term is 6,375. You can just plug that into your calculator. So let's look at that. 1,275 divided by 2, open brackets, the first term is 5, the last term is 6,375. This gives us the sum of 4,000,000. Let's check that, the rest of that number, 67,000 250. Okay, all right, simple enough. Or alternatively, I mean, if we did not have the last term, if we did not have this term here, we could have used the other SN formula. It's much longer. This is it. We could have used this formula. Okay, and of course, the number of terms we know is 1275. 2 times the first term, which is 5. All right, and n, of course, again is 1275 minus 1. This is d, the difference, and we have a difference of 5. Okay, so if you want to just simplify this a little bit further, 2 times 5 is 10, and if you subtract 1, 1275 minus 1 will be 1274. Multiply that by 5. I think it's simplified enough. And then of course you would go to your calculator. 1275. Okay, it's 10 plus 1274 times 5. Okay, so what you will find is that both formulas are giving you the same answer, okay? But you didn't have to use this one because for this particular question you had the last term. But if you do not have the last term, then you have to use this formula. Okay, let's move on now to the geometric sequence and series, okay? Our Tn formula for the geometric sequence, this is it here, A multiplied by the common ratio to the power of n minus 1, okay? And our sum formula or the series formula, our Sn, is A, open brackets, 1 minus r to the n. At the bottom is 1 minus r. And of course, r is the common ratio. All right, and linked to that would be our sum to infinity formula. So it's just A 1 minus r as a denominator. And we're going to get to that. Okay, so let's put these formulas to some application. Okay, so find the next two terms. Okay, and as you can see, to get the next term, we multiply by a half each time, right? So that means our ratio is a half. Another way to get this ratio would be to say term 2 minus term 1, okay? Or you could have used term 3 minus, term 2 divided by term 1, not minus. This is geometric, so here we're dividing, we're not subtracting. So what would be our ratio then? Term 2 is 25 and term 1 is 50, which gives us a ratio of a half. We already know that because 50 multiplied by a half is 25. 25 multiplied by a half is 25 over 2. All right, so that's our term 3. So the question is asking us to calculate the next two terms. Okay, of course, we're going to use that ratio, the common ratio. So to calculate term 4, we'll take term 3 and we'll multiply it by half because our common ratio is a half. So term 4 will be 25 over 4. Okay. And then also to calculate term 5, then we would take term 4 and also multiply it by the common ratio, which would give us 25 over 8. Okay, so let's answer more questions. Finding the n term should be much easier. We know the formula for Tn. For a geometric sequence, this is the formula. So what's A? A is the first term, which is 50. What's R? R is the common ratio, half, because we keep multiplying by a half each time, and minus 1. So that would be our nth formula, the general formula. Okay, let's move on. So the formula has been typed again. So how do we then find the 10th term in the sequence? That's easy. We would, of course, use our formula, which we've got here. And 10 will be 10 minus 1, which of course we could simplify to 9. And then we could calculate that out. Okay, so our 10th term will therefore be 25 over 256. That's the value of the 10th term. All right, so for 1.4, we need to check if this fraction is actually a term in the sequence. And of course, these questions is where you substitute a term into Tn, and if you get a whole number, then it is in the sequence. If you do not get a whole number, then it's not in the sequence. Similarly to what we did when we look at number patterns. Okay, so our Tn, of course, we know Tn is equal to 50. Right, that's our Tn. Okay, so let's equate our Tn to the fraction. So we've got all right, okay. So to simplify, of course, let's do it over here. To simplify, we could just divide both sides by 50. Okay, if we divide both sides by 50, and that also by 50, we will get 1 over, right? So what happens if we divide 100? So 100 over 32, and we divide that by 50. Okay, we get 1 over 16. And of course, this could be written as alright, please revise your exponents if you do not understand what we did there. And to go further, we get now that the bases are the same, we can equate the exponents to one another. Okay. All right, so this is so n is therefore equals to 5. So yes, that is the fifth term in the sequence. So yes, because 5 is a whole number, yes, it is the fifth term. So that is a term. This is the fifth term in the sequence. Okay, so because we get a whole number, so I repeat, for these questions, you're always going to equate whatever is term is being asked, is being checked into, you substitute that into Tn, and if n is a whole number, then it is a term in the sequence. So remember that. Okay, let's go further. Consider the geometric series below. Okay, we know that this is geometric because you're multiplying each time. What are you multiplying by? 2. 5 times 2 is 10, 10 times 2, and so forth. So how do we then find the number of terms. So that's Tn, which we know is a Rn minus 1. Okay, so a in this case is 5. The ratio, the common ratio is 2. You keep multiplying 2, n minus 1. Okay, that is basically our Tn formula. And of course, remember, this is similar to when we did an arithmetic sequence. To check the number of terms, you must equate Tn to the last term. Okay, the last term tells you how many terms there are. So if you equate the last term to Tn, that's the last term, then you will find out how many terms there are. So if you divide both sides by 5, so if we divide 655,360 by 5, we find 131,072. Okay, and of course, to get that number, we would have to use the base of 2 and the exponent of, let's just try out, trial and error, an exponent, let's say 15, if you say 16, 17. All right, so 17 gives us that number. So 2 to the power of 17. So now that the bases are the same, we'll equate the exponents to one another. So we've got n minus 1 equals to 17. So therefore n is 18. Okay, so there are 18 terms in this sequence. Okay, and of course we have used the last term to figure out the number of terms in the sequence or a series. Okay, to find the sum, then we use the sum formula. There's only one for geometric series, which is, right, again, it's given in the formula sheet. Okay, so we know that A is the first term, and the first term is, of course, 5. Okay, the first term, just wanted to show you there. The first term is 5. Okay, there. So A is going to be 5. 1 minus the ratio, you keep multiplying 2, so R is 2. Okay, and of course, we can just substitute 18 because we already know there are 18 terms. So let's just substitute 18 into n because there are 18 terms. It's 5, of course. All right, so then we go to our calculator to check the sum of all the 18 terms in this sequence. And of course, it will give you 1,310,715. Okay, that is the sum of all the terms in the sequence. All right. Okay, so let's look at the final question, which is the sum to infinity. So if you have to find an infinite number of terms, of course, the formula then becomes A1 minus R. This is the formula for infinity. Okay, so if we look at A is 5, we know that. And of course, 1 is 1 minus the common ratio. It's 2. You keep multiplying by 2 each time. So to find the number of the infinite number of a geometric sequence, this is basically how you would do it. Okay, so therefore the infinite number in the geometric sequence will be -5. Okay, so that is the sum, infinite sum of all the terms in the sequence. Okay, all right. Now, does the series converge? To see if the series converges, r has to be between -1 and 1. Okay, converge means it's going towards 0. Otherwise, it diverges. Okay, so if it's between -1 and 1, then we'll say that that particular series converges. But if we check the value of r, we already know the value of r is 2. Okay, we didn't even have to calculate it, it was obvious. Right, of course, if we had to calculate it, we'd take term 2 and we subtract or divide term 1, sorry. So which would be 10 divided by 5, and it would give us r of 2. We already know that r was 2. And this r, of course, is outside that range. It's not in that range. So we would say no, it diverges. It doesn't converge, it diverges. Okay. Okay, because it's not in that range. Okay, grade 12s, well, this is where we come to an end. Remember to like this video. If you have not yet